Okay, now take the leads off the battery again, off this. Okay, what you and take that 0.18 off in the box. So right now they actually use a voltage drop. Now remember, what's the voltage drop check for? Anybody remember? Corrosion resistance, like we talked about yesterday. It checks for resistance. Okay, so what they're doing is, here's the cables. You can kind of draw this.
I can't see.
Oh wow, yeah, I can't see my screen, huh?
What about if I give you remote control?
Yeah, see if that happens. Yeah.
And then
Oh no. Okay, no. Stay where you at. Take the red lead. Take that red lead again, and go to the alternator positive. Right there. Now it's actually, now you see that circle in the top left? Point to that, the top left on the alternator. Up. Right there. You see that? That's the same connection there. Okay, that's what you're on the red lead. Now take the black lead and go to the least positive of that same charging system circuit, which is that cable exactly right there. The alternator, which is the top left, point to the alternator, Gabriel, right there. That alternator charges the battery. So that's the most positive side of the circuit. Okay, the battery cable on the other end is the least positive side of that circuit. So we're doing a voltage drop on the positive side. We're doing a voltage drop on the positive side of the charging circuit. All right, so we're doing a voltage drop on the positive side of that charging circuit. And I said this before. What about the leads of a voltmeter? When you're using a voltmeter, what's important about the leads? Anybody remember?
That they make contact.
Yeah, they make contact. That's true. Make good contact. That's actually true. And also that the leads, you're checking what's in between the leads. Now look at that picture. Now imagine, hey Gabriel, do this. Take the red lead off the alternator, big picture, the blown up picture, and just put it over to the alternator. No, put it on the alternator, the actual alternator. No, not that one, the other one. Let's hold it there for a second. Now look what he's checking. You got the red lead on the left, the black lead on the right. He's checking what's in between the lead. Okay? What's in between the lead? It's actually a very good picture of this example. He's checking what's in between the lead. And what's in between the lead is what? The battery, or the voltmeter leads are what?
A load.
No, not the load. Well, it's kind of a small load, but not a load really. But what's in between? Look at the positive cable and the black cable. What's in between it?
A circuit.
Yeah, it's a circuit, but it's one particular part is in that circuit between the two leads.
Flywheel.
Say it again.
Flywheel.
No.
What's the generator?
What's the
alternator?
No. Actually, the alternator's on the other side of the lead, right?
Potential has got a.
What's that red thing in between those two leads of the voltmeter? No. It's connecting the alternator to. It's connecting the alternator, the cable. Take a good look at it. It's the cable that's in between the leads.
Yeah.
Remember, it's the cable in between the leads. So we're doing a voltage drop on that cable. Now put the red lead back, Garcia, back on the alternator. The actual blown up picture, where it stays by itself, right there. Now move it back over. Yeah, here, that's sensitive. You gotta be in the right spot. Right. So he's checking what's in between the leads. So when that car is running, the alternator is charging the battery. So it's sending current through that battery. What's in that cable? Copper wire. Like we talked about yesterday. What you're doing is checking for any bad wiring inside that cable. And how do you find that? What's that term called again? It ends with a drop.
Voltage drop.
Yes, you do a voltage drop to find resistance, right? So you're basically doing a voltage drop to find resistance, and that's what you're doing right now. That cable, if I remember correctly, I think the maximum voltage drop in the alternator is point 0.2 in the cable. I think it's 0.2. It's a 0.3? Is it 0.2 or 0.3? I think it's 0.2 though. I can't remember.
0.2, I'm sorry.
Yeah, it's 0.2 or less across the cable.
Yes.
If the alternator is not charging correctly, you're gonna have a voltage drop over 0.2.
No. That's a very good question. No, actually not, because I'm not checking the alternator. This check you're doing right now is not checking the alternator at all. It's only checking what's in between the leads. And what's between the lead is the cable. That's it. Now, let's look at this, though. Let's look at it this way. Right? Let's say that let's say that alternator wasn't charging. I mean, you got to charge, the light comes on. Right? For a charging problem. And your local mechanic says, oh, you have a bad alternator. You put an alternator in it. And it still has a charging problem. Oh, they go get another alternator. Put another alternator in. And it still has a charging problem. Maybe there's something that's wrong with the car. Okay? Maybe you got to check the voltage going to the alternator. Or maybe the cable has resistance in it. And the alternator, now pay attention to this. Y'all should know this from yesterday. What we did yesterday. The alternator is charging correctly. Let's say 14 volts. Okay? And let's say the meter right now showing you almost 0.2 of a volt, 0.1, 1800ths of a volt. Right? So it's showing you 0.18 volts. Okay? Let's say that cable was shot. And it shows you 5 volts. Right? Let's say it shows you 5 volts. How much voltage would be left on the alternator charging that battery? If it was a 14 volt system? 9. A battery needs 13.5 volts or higher to charge. If I got 9 volts on a battery charging, that battery never to charge up. And changing the alternator is not going to fix your problem if that cable has resistance in it.
So, for example, this one has 0.18. It's too much resistance.
No, that's perfect. That's almost 0.2 of a volt. That's perfect. Anything less than 0.2 is good.
So it's 0.3. That's too much already.
Yeah, 0.3 is a little high also, but I'm not chasing them for 0.3 unless you got a problem.
But 0.3 or say 0.8.
Now it's kind of high. I would check the contacts. Anything over 0.2 is high.
I would have to change the cable too.
No, you got to find out. It could be the cable. It could be the contacts. Anything between the two leads can cause that. Remember, anything between the two leads. It could be the contact.
Tell me what you're gonna do. Okay.
It could be the contact. It could be the cable itself. Could cause a problem. So basically what you're doing, that 0.18 is a good reading. It's showing there's no resistance in that cable. It's like you can have, like we talked about yesterday, you can have a strand of wire, this red insulator, you can never see a bad strand. By doing this test here, which is a voltage drop, you can see a bad strand. I mean, you can't see it, but you know you found a bad strand of wire inside that cable. The meter is telling you there's a problem. Like using the meter, it can tell you have a problem or not. This reading is good. There's nothing wrong with this one. This is a good reading. Everybody understand that? I know a voltage drop is kind of hard to understand comparing to like checking for a potential voltage or available voltage at a part. Checking for potential voltage or available voltage at a certain point is easier to understand than a voltage drop. Because a voltage drop, people get confused with this because you're checking at 2 certain points for resistance. And what you're checking is what's between the 2 leads.
Which is the same cable going from point A to point B.
I'm sorry, say it again.
So it's like is the same keep what you're checking, but you're putting it from point A to point B.
Exactly. Yes. Yes. And remember, when you do a voltage drop, you're checking for resistance. Okay, that's why you do this test. You're not checking for available voltage, right, at a certain point. All right, you're checking a potential voltage. You're checking for resistance when you do a voltage drop. And remember, like we said before, in the Ohm's law, we talk about resistance, right, and we give it a number. But in reality, you can't really see resistance unless you see corrosion. Like in this cable, if you had a stranded wire that's bad, you can't see that. If you do a voltage drop, the meter would tell you you have a problem. Anybody have any questions on that? All right, Garcia, you can stop sharing your screen now.